Okay, number 1. Question number 1 says, identify the transformations from the parent function. Okay, so we notice that the variable x is raised to the power of 2. That means that it is a quadratic function. Okay, it's a quadratic function because its variable x is raised to the power of 2. So the parent function is the function without anything done to it. So the parent function would be y equals x squared. Okay, it's a parabola. For the given function, there's 2 transformations. The leading negative means that it is an x-axis reflection. So what has happened is that the graph is reflected over the x-axis, so it opens downward. Okay? And that 2 indicates that the original parent function has been vertically stretched. It is a vertical stretch by a factor of 2. Okay? And so what happens is the parabola gets narrower. The parabola gets narrower. Okay, so our transformations again are here and here. Does anybody need more time on number 1? Okay, number 2. Number 2 says, what is the inverse of the function? So the function is an exponential function. How do we know it's exponential? It has x in the exponent. It is an exponential function. So in order to create the inverse function, we follow a series of systematic steps. And what we'll end up with is a logarithmic function because exponential functions are inverses with logarithmic functions. So step 1 is we switch x and y. X equals 4.5 to the power of y plus 11. Step 2, we isolate the exponential part. Subtract 11. Step 3, we convert it into logarithmic form. So currently it's an exponential. To get the inverse, we switch to log. Log base 4.5 of x minus 11 equals y, or f inverse of x. Okay, another way that we can see it, just to show you one more example, is change of base formula. So this could also be seen as log x minus 11 over log 4.5 equals y. When I stick this into Desmos, I should see the functions reflect over the line y equals x, because that's indicative of inverse functions. They reflect over the line y equals x. Notice our inverse function is a logarithmic function. Follow those steps. Switch x and y, solve for y. Let me show you in Desmos what it would look like so that you can recognize that they are exponential. Sorry, not exponential. Recognize that they are inverses is what I meant to say. Sorry. Y equals 4.5 to the power of x plus 11. Okay. So let me there's that one. Okay, and then our inverse we said was y equals, I'm going to go to functions, log base, sorry, I forgot it. Log base 4.5 of x minus 11. Log base 4.5 x minus 11. Okay, look, you can see the black function and the red function. Now watch when I type in y equals x. Do you see how they reflect exactly over that line? That's indicative of inverse functions. Exponential are inverse with logarithmic functions. Okay? Go back. Yes, I will go back to number 1. Does anybody need more time on number 2? Okay, let me go back to number 1. Just tell me when you're ready. Oh, okay, why I went to that last part. I just did it so because sometimes once you get into logarithmic form and you have log base 4.5 of x minus 11 equals y, you can see it one step further. Like sometimes on your standardized test, it may put it just into change of base formula. So log base 4.5 of x minus 11 is the same thing as saying log x minus 11 over log 4.5. Yeah, it's just the same thing. It's just another way to see it. Okay, let me go back and just show you that. Okay. Okay, so just real quick, Antonetta said, why did we go from this to this? It's the same thing. It's just in change of base form. Okay. All right, number 3. Number 3 gives us a linear function, and we have to find the value of f inverse of negative 20. So when we have a given function and we have to find the inverse of the value, we plug the value in for y and we're solving for x. So essentially, write yourself plug into y, solve for your x value. Okay, so I'm going to say negative 20 equals 2/5 x minus 8. Two-step equation, add 8. Negative 12 equals 2/5 x. Multiply by the reciprocal to get x alone. So x equals 5/2 times negative 12, which would be negative 60/2, which is negative 30. Okay. So essentially, on our original function, the ordered pair negative 30 comma negative 20 lies. And so on our inverse function, negative 20 comma negative 30 lies. Because they are inverses, the XY ordered pair flips. Okay, take a minute, make sure you've got that. Does anybody need more time here on number 3? Good? Antonetta, you good? Okay. Okay, number 4 is a quick, easy, fast, simple, look at it, know the answer. Okay? This is the standard form of a circle. you could do one of two things. You can stick it directly into Desmos and identify the center, or you can remember that standard form is x minus h squared plus y minus k squared equals r squared. HK is the center, and the square root of r squared is the radius. So for this particular given equation, what would the center of your circle be? 3, -8. And what would the radius length of the circle be? What's the square root of 121? 11. Good? Okay, now let's say you come in on Monday, May 24th, and you're having a moment and you cannot remember how to do this. You use Desmos because Desmos is available to you. Watch this. You put it in exactly the way that you see it, x minus 3 squared plus y minus 11, no, what am I saying? Y plus 8 squared equals 121. Okay, now, of course, when you do it this way, it takes a little bit of legwork here on your own part because it is a little bit hard to see. But you could go here, 3, -19, okay, 3, -19, and then go directly above it, 3, 3, okay? So obviously your center is 3, and then we go here. Well, it's not going to give us a point, but you can pretty much use counting techniques. I think it's harder to graph in Desmos because you got to do all the little counting of the spaces, but it's just a way that you can see if you're correct. Okay? All right. Number 5, excuse me. Isaac deposited $13,500 into an account, earning 9.5% interest compounded quarterly. Find the amount in the account after 15 years, rounded to the nearest whole dollar, if no withdrawals or deposits were made. Okay, we talked yesterday about the term compounded, right? Or maybe it was the other day. When you see compounded interest, you need to use A equals P, 1 plus R over N raised to the NT. We don't know the final amount. That's what we're looking for. What's our principal amount here? The initial deposit is the P. Interest, R. Time is 15 years. We need to know compounded quarterly. Okay? All right, let's set it up. 13,500 parentheses 1 plus 0.095 over 4 raised to the power of 4 times 15, which is 60. That looks like 4.15. Let me fix that. 4 times 15. Okay, N times T. And then we stick it directly into Desmos to compute the amount to the nearest whole dollar. 13,500, 1 plus 0.095 divided by 4 to the power of 4 times 15. Or I could just put 60 up there. Okay, and he would have $55,204 if we rounded to the nearest whole dollar. $55,204. Okay, plug straight into Desmos after you have it set up. So as you can see, you need to know this formula here. Any questions on number 5? All right, number 6. Given the function x cubed plus kx plus 17, and the remainder when f of x is divided by x plus 1 is 26, what is the value of k? And then what is the remainder when the function is divided by x minus 1? Okay, this is a classic EOC style problem. It's asking you to do multiple skills. It's testing you on multiple skills from the polynomial unit. First thing is, they tell us that when this function is divided by x plus 1, the remainder is 26. Okay, so that means when we plug f of negative 1 in, because look at what we're dividing by, x plus 1. So when we plug negative 1 in, the remainder is 26. So the first thing we're going to do is find k. We're going to say 26 equals negative 1 cubed plus k times negative 1 plus 17. Negative 1 cubed is negative 1. Negative 1 plus 17 is 16. So we are at 26 equals 16 minus 1k. Subtract 16. Negative 1k equals 20. Is not 20, geez, 10. So what does k equal? Negative 10. K equals negative 10. So now we have f of x equals x cubed minus 10x plus 17. All I did was solve for k, plugging negative 1 into the function for x, setting it equal to 26, solved for k. Now, I'm going to use synthetic division to find the remainder when the polynomial is divided by x minus 1. So this is part 2. So on the outside of my synthetic division, I'm going to use 1. On the inside, I'm going to put a 1. And then I'm going to put a 0. Why am I putting a 0? What's missing? X squared. And then I'm going to put a negative 10. And I'm going to put a 17. Drop, multiply, add, multiply, add, multiply, add. What is the remainder when f of x is divided by x minus 1? The remainder is 8. Okay? So remember, two-step process. I plugged negative 1 into the function, set it equal to 26 to solve for k, used k, plugged it back into the original function, and did synthetic division to find the remainder when it was divided by x minus 1. Any questions on number 6? Number 7. Find all of the vertical asymptotes of the function. Okay, so remember, vertical asymptotes are what's left in the denominator that makes the denominator 0. So the first thing we do is factor the top and factor the bottom. The top, we can pull out a GCF of 2. On the inside would be 3x plus 7. At the bottom, two numbers that multiply to give you a negative 14, add to give you a negative 5. Anybody want to factor that? Thank you, Antonetta and Ben. X minus 7, x plus 2. So then you say to yourself, what? So first, there's nothing to cancel. So because there's nothing to cancel, there are no holes. So the two factors at the bottom serve as your vertical asymptotes. The two vertical asymptotes are whatever values of x make the denominator 0. What are your vertical asymptotes here? Perfect. X equals 7. X equals negative 2. Let me run you over to Desmos really quick so that you can visually see those vertical asymptotes, okay? A lot of times it's good to get a picture in your mind. So I'm going to go over to Desmos. And at the top, I'm going to go 6x plus 14. Divided by, at the bottom, x squared minus 5x minus 14. Okay, you can see here at 7 and then at negative 2. There's your asymptotes. It gets really close to, but never touches or crosses. Okay. Yes. I'll go back to number 6. Just let me know when you're ready. All right, number 8. Number 8 says Marco can paint his living room in 9 hours. With help from his friend Harry, Marco can paint the same size room in 5 hours. How long would it take Harry to paint the living room alone? Okay, so we're going to use that work rate formula. 1 over time alone plus 1 over time alone equals 1 over time together. We have Marco, we have Harry, and we have their together. Marco does it in 9 hours, 1 over 9. Plus Harry, we don't know, so he's 1 over x. But we know when Marco and Harry work together, because it says with help from his friend Harry, Marco can paint the same size in 5 hours. That means Marco and Harry are working together. So it equals 1 over 5. 1 over time alone plus 1 over time alone equals 1 over time together. You have denominators of 9 x and 5. You establish a common denominator. What do 9 and 5 both go into? 45. So we're going to make a big parentheses around everything and multiply everything by 45x. So we have 45x over 9 plus 45x over x equals 45x over 5. We simplify. 45x divided by 9 is 5x. 45x over x is 45. 45x over 5 is 9x. Subtract 5x. Sorry, I got to work upwards. 45 equals 4x. Divide by 4. 45 divided by 4 tells us Harry's time it will take him if he works alone. 11 and a quarter hours. 11 and 1/4 of an hour. So 11 hours and 15 minutes. X equals 11.25 hours. 11 hours and 15 minutes. Okay. Make sure you have that work rate down. You'll probably see one on the exam. 1 over time alone plus 1 over time alone equals 1 over time together. Number 9. Somebody's not done, sorry. Can you see it now? Okay, tell me when you're ready. Okay, number 9, 2 more. Number 9 has a triangle, QRP, inscribed within a circle. When you have a triangle inscribed in a circle, and one of the sides of the triangle is directly across the diameter, what do we know automatically about angle P? We see that this is a right triangle. It's inscribed in the circle. QR is a side of the triangle that is also the diameter of the triangle. So automatically, you should know and recognize that angle P is, thank you, Korea, is a right angle. This is 90 degrees. It does not tell us that it's 90 because there's no visual symbol there, but we need to know it. That's a 90-degree angle. That means that 4x plus 3 plus x plus 7 plus 90 adds up together to 180. That's all 3 angles of the triangle is 180 degrees. Combine like terms. 5x plus 3 plus 7 plus 90 is 100 equals 180. And then it's a two-step algebraic equation. 5x equals 80 when you subtract 100. Divide by 5, x equals 16. Now, they didn't ask us what x is. They asked us for the measure of QRP. We plug 16 back in here. 16 plus 7 gives us the measure of angle QRP. QRP as 23 degrees. Anybody need more time on number 9? Okay. All right, number 10. Write the equation for a circle with a center at -6, 9 and a radius of 4. This brings us back to the question that we did a few above. I can't remember the number, but we're going to use the formula x minus h squared plus y minus k squared equals r squared. All we simply have to do is plug the center in. X plus 6 squared plus y minus 9 squared equals r squared. 4 squared is 16. Final answer is here. Okay, it is 7:55. You have 50 minutes to work on EOC review number 3. And if you have been slacking, EOC review numbers 1 and 2 as well. Okay, remember the average of numbers 1, 2, and 3. I will add them together and divide by 3, and that will be a formal test grade. There's no retest because you get 3 attempts on each assignment. Okay, so use those attempts wisely. And we are done.